All right, so let's start. Make sure I'm recording it. I'll send her the video. All right, this is lesson 66. 66 on page 268. All right. We're going to be simplifying radicals. All right, so the steps to simplify radicals. First of all, what's a radical? It has that sign, right? It has this sign. It can be a square root, it can be a cube root, fourth root, any root, all right? Here's my steps. First thing I'm going to do is simplify each term. Each term in the expression. Okay, what does that mean? Well, let's suppose I have 2 square root of 12 as one of the terms in the expression. That means I'm going to simplify that square root of 12 because I know that square root of 12 is 4 times 3, right? So that's the same thing as 2 times the square root of 4 times 3. And I can unsquare the 4, can't I? What's the square root of 4? So it's 2 times the square root of 3. What's 2 times 2?
4.
So it's 4 times the square root of 3. So the first thing I'm going to do is,
That's how you simplify.
That's how you simplify that expression, right? I don't want anything under the radical that's a perfect square that can be pulled out like that 4.
So that side is a radical sign?
Yes.
It kind of looks like
Square root?
Yeah.
It is a square root.
So that's
It can also be a cube root. It can also be a fourth root. So I just generically write it. It's called a radical.
So
The big generic name is radical.
so these are the same thing?
Yes, certainly are.
Can you do like another example?
Okay, we're going to work all the examples. So that's the first step you do. All right. The second step is I look to see if I have any like radicals. What's a like radical?
Radicals are the same with the same square root.
Yes, yes, all of those are like. And for the like radicals, I'm going to add them. So suppose those were added.
Oh, so it's gonna
Okay, this is exactly the way we do something like
it's gonna be 9.
9 to the square root of 3.
9 square root of 3. That's right, we're adding 1 plus 2 plus 6. The radical doesn't change. It's the same thing like 2x plus x plus 6x, right? That's 9x. Okay, so these are like coefficients,
That's not bad.
okay? But if I would have added this,
Then
it is not like.
It would just been 2 plus 9 to the.
It would have been square root of 2 plus 9 square root of 3.
just do like
So you're only adding your like radicals.
Wait, that's the whole lesson?
That's this lesson
Okay.
and part of it. That's the first part. All right. So let's work through the examples. The next part is simplifying the radicals. Simplifying very large radicals. Look at example 1. Square root of 18 plus square root of 8. All right, first thing I do is I simplify them. Is there a perfect square that goes into 18?
2.
2 is not a perfect square. 4 is a perfect square.
Oh.
9 is a perfect square. 25 is a perfect square.
No, perfect squares. Don't do it.
What times 2 is 18?
Oh, 9.
9. This is the same thing as the square root of 9 times 2, right?
Okay. Oh, okay, yeah.
Can I unsquare the 9?
Yes.
What's the square root of 9?
3.
So it's 3 square root of 2. Got it?
Got it.
Okay. What about 8? Is there a perfect square that goes into 8? 4. It's 4 times 2. Can I n square the 4?
Yes.
Yeah.
What's the square root of 4?
2.
2, so it's
So
gonna
it's
be
plus
2,
2.
2 square root of 2.
Yes, exactly. Do I combine them? Are they like?
Yep.
Yes.
So it's
So
gonna
it'd
be
be
5
5
square
square
root.
That's right. 2 plus 3 on the outside is 5 square root of 2. Make sense, ladies? All right. Let's look at the next one. It's a little more complicated. All right, it's 8 square root of 27 minus 3 square roots of 75. All right, 27. Any- 9 times 9 times 3. Notice I'm writing that under the radical, right?
Yeah, so then you can.
So that I can unsquare
The 9, so it's gonna be 3
so it's 8
times.
times 3 times the square root of 3.
So then you can still simplify it.
What's 8?
24 to the square root of 3.
24 square root of 3. See what I'm doing?
Okay, so then.
All right, so now minus, I'm leaving that, okay, the 3 stays, I might simplify. 75, perfect square,
5. 25.
25. It's 25 times what?
30.
3 is 75. Can I unsquare 25?
Yes.
Yeah.
5.
So it's times 5 times, what's left under the radical?
3.
3.
The 3.
So it's 15.
15
Square
square root
of 3.
of 3.
It's gonna be.
24 minus
so it's gonna
15,
be 9 square root of 3.
9 square root of 3.
This is actually.
So see, we're simplifying first, and then we're combining like terms.
Wait, this is the whole lesson?
Well, no, there's another part, but it's very much related to this. All right, look at the third example. Square root of 27 minus 3 square root of 18 minus 6 square root of 45. Can we simplify square root of 27?
9
9
times 3.
9 times 3 under
So
that
it's
radical.
Square root of 3.
So it's 3
Square root of 3.
square root of 3. What about 18?
Okay, 18, yeah. 9 times 2. Or so it's gonna be
3
9
to the
square
3
root of
times
2.
2.
It's gonna be 9 square root. It's gonna be 9 square root.
That's right, it's gonna end up being 9 square root of 2. 45. That's right, this is one we haven't had.
9 times 5.
That's right, 9 times 5.
And then it'd be 6 times 3 to the square root of 5, so it'd be 18 to the square root of 5.
That's 18 times square root of 5. This is 9 times square root of 2. This is 3 times square root of 3. Do I have any like terms?
Nope.
7.
No like terms. So I cannot simplify that any further.
Okay, so why do we simplify?
Because in the future, you're gonna have to simplify. And then you're gonna have to reduce and cancel. Like you're gonna do this from here on out. The two that I always memorize is the square root of 12 is 2 square root of 3. Like I know that. The square root of 12 is 2 square root of 3. The square root of 20, so these are the two that I see most often, is 2 square root of 5. I have these memorized in my brain. Okay? All right, the next one. We'll work the next example. Example 4. Okay, these are large. Now we're getting to large roots. Okay. When we have large roots, very large numbers, like, okay, that's not very large.
Wait, so 20 equals 2 square root of 5?
Yes, because it's 4 times 5.
Uh,
Memorize it, okay. When I have very large radicals, I take, if there's an even number of zeros, I take the square root of the number and half the zeros. The square root of the number and half the zeros. I'm gonna take half the zeros because there's an even amount. I'm gonna take the square root of 9.
Oh, so that's it?
Make sense?
Yeah.
Okay, but they're gonna be bigger. Okay,
500? Wait,
So it's gonna
no,
be
10.
I'm gonna take
zero,
half the zeros, which is 100.
Wait, so basically figure out like,
Wait,
so
half the
30
zeros
times-
is 100? Why is it 100?
Okay, I'm gonna see this as the same thing as the square root of 5. So I'm gonna see this one as the square root of 9 times the square root of 100.
that'd be.
I'm gonna see this one as the square root of 5 times the square root of 10,000. I have 4 zeros, I'm taking half of them, that's 100. I'm gonna leave it times the square root of 5. I cannot unsquare 5. I can unsquare the 9, I can't unsquare 5. All right, what if I had square root of 500,000? I'm only taking out an even number. So I'm gonna leave this as the square root of 50 times the square root
100, 1,000.
of 1,000, right? I'm only taking out an even number. Okay,
1,000.
because this is what?
That,
What, 1, 2, 3, 4, 1, 2, 3, 4. I meant to take it, I left 1 here. I'm putting the 4 here. 4 zeros here.
so the square, what's the square root of 10,000 is?
Take half of the numbers, half of the zeros.
It'd be 100, but then the square root of that is 10.
No, this is the square root of 10,000, which is 100. Take half the zeros, half the zeros.
But the square root of 100 is 10.
I've already unsquared it. I don't take the square root again.
Right.
This is the square root of 50,000 times the square root of 10,000. The square root of 10,000 is 100. Make sense? Okay, what about 50? Can I simplify 50?
25.
25 times,
2,
25 times 2.
5.
So it's 5 times the square root of 2 times 100. I can multiply what's outside the radical.
Wait, how do you not do 5 outside of it?
So 500 square root of 2.
Square root of 25 is 5.
Wait,
I left 2 under the radical. I left the 100.
so it's gonna be 500 square root of 2.
500 square root of 2.
That's
Thanks.
hard. Well, it's just kind of confusing.
All right, what about 40 million? Square root of 40 million. All right, do I have an even number of zeros? How many even number of zeros do I have?
4.
Let's take this out. What's it gonna be?
I don't know, 100,000.
Wait.
If I take 6 zeros out, what's it gonna be?
A million.
It's gonna be the square root of a million, but when I take it out, I take half the zeros? A 1 with 3 zeros. Okay, I've taken care of that. Times the square root of 40. You see what I did? I'm taking an even number of zeros out.
It's gonna be 100. Wait, no.
40, do we have, what,
times 2?
is 20 a perfect square?
No.
5 times 8.
5 times 8.
Yeah.
Is 5 a perfect square?
No.
Is 8 a perfect square?
4 times 10.
4 times 10. So this is 1,000 times the square root of 4 times 10.
So it'd be 1,000 times 1,000 the square root of 2 times.
It's got 1,000 square root of 40.
Oh, 1,000 times 2 times 2.
I unsquare the 4, square the 4 is
2.
2. I leave the 10 under the radical.
Okay.
I
So
multiply,
2,000 square root of 10.
it's 2,000 square root of 10. Pull out half the zeros with a 1. An even number of zeros. Leave the rest under the radical. All right, let's do 700 million. All right, what is the square root of 700 million?
The zeros is 4, so it'd be
Oh yeah, I can take all these zeros out because they're 6, 7, 8.
So it'd be 10.
So it's 1 with 4 zeros, half of them, right?
So it'd be 100.
Times the square root.
Of 7. That's the answer.
That's the answer.
Wait, wouldn't you simplify 10,000 more?
10,000 is out of the radical. When I take full half of the zeros, it comes out of the radical. Does that make sense, ladies? Taking half of the zeros,
Alright.
leaving that, got it?
That's really confusing.
Take out an even number of zeros. I'm gonna pause the recording. And I want y'all to work the practice problems.
Is that possible?
All right, this is lesson 67. So we have had simultaneous equations or a system of equations where we've used substitution. So we may have had an equation that looked like this. Two equations that look like this. We took this piece of the equation and substituted that in for y and solved for your x and your y variables. So that is one way to solve problems, to solve a system of equations, is through substitution. We're going to learn the other way today. It's elimination. All right, so we're going to eliminate a variable. In order to eliminate a variable, okay, I'm going to just look at the second equation. In order to be able to eliminate a variable, we have to have the opposite coefficient. So if I'm going to eliminate x, and this is 2x, in my other equation, it has to be negative 2x. It might not be negative 2x to begin with, but I can use multiplication and make it negative 2x. All right? So we're going to eliminate a variable by having opposite coefficients. Okay? To make sure it has that opposite coefficient, we may have to multiply every term in one of the equations by a number. All right? So I want us to look at example 1 on the bottom of page 272, and we will walk through this. All right, so we begin with 2x minus y equals 13. That's the first equation. 2x minus y is 13. Yep.
What are we going to be doing for our final?
I'll give you a final review. It'll be over the whole year. But everything is incremental and builds, right? So it will obviously be weighted towards the end because those are your harder problems. Everything we're laying foundations and building upon it.
So it'd be like.
So at the very end, what you've learned here depends on what you've learned at the very beginning. Because it's all foundational.
I don't get that, because why can't they just have like 2 midterms? I wish.
It really is almost like 2 midterms. Okay. So we're going to use the elimination. I look at my x variables, my coefficients. 1 is 2, 1 is 3.
The 2x is equal to.
I really want to eliminate my y's because that's negative, that's positive. If I multiply this first equation by 4, if I multiply every term in this first equation by 4, I end up with a -4. Then I can add them and it will eliminate. All right, so that's what I'm going to choose to do. Multiply every term by 4. It goes to every term.
Wait, so 4y doesn't, it's not 4y?
It'll be -4y. All right, so watch. 4 times 2 gives me 8x. I'm going to multiply and put the result below this equation. The second
Wait, so
equation.
you just chose, could you have chosen 3?
If I would have chosen 3, I'd have had to multiply this
Wait,
by
why
-2.
4?
Because this is a +4, this is a -1. I want this to be -4.
So if there's a negative number, you always take the negative number.
I always want to take the ones that are opposite signs if I can.
No, but we have a choice, or on a test where we have to do this way.
If it says elimination, you have to eliminate. If it says substitution, you have to substitute. If it says solve, you have a choice.
All
right.
This way, it's too confusing.
So 4 times -y is -4y. What's 4 times 13?
Something.
5.
Is it 52?
52, yeah.
52. All right, now I'm going to take these 2 equations. I'm going to add them. 3x plus 8x is how many x's? I have 11x. What's 4y minus 4y?
So why do the negative?
What is y?
I eliminated y. My y eliminated.
Okay.
What's 3 plus 52?
Gee, I don't know.
55. You see, I now have an equation that only has one of the variables.
Don't you just x equals 5?
That's right. I divide by 11 on both sides. X equals 5. Am I done? No. I have to solve for y.
Okay, so x equals 5, you're going to keep that.
I'm going to go back into one of the original equations.
You're going to go back to the.
I'm probably going to go back into the 2x minus y equals 13. Just feels easier.
Okay, so it's going to be 10. Okay, I can do
Yes, 2 times 5 minus y is 13.
It's going to be 10.
This is 10.
10 minus y equals 13.
I'm going to subtract 10
Yeah,
on both sides.
so it's going to be 3. So
Negative y equals 3.
Wait, yeah, equals 3.
Why
Divided by negative.
Because 2 times 5 is 10.
So it's going to be, so y is going to equal negative 3.
equals 5, you have to plug
Y
in
equals, y equals -3.
So I changed the signs. Yes. It's like I multiplied every term by -1 to change that to positive.
Like once you get one of them, it's not hard to substitute it.
That's right. That's my solution. X, Y ordered pair. What does that mean? That means on the coordinate
We already
system
learned this, right?
at 5, -3, that's where they intersect. That's what we're solving for. Yes. All right.
We already learned this, I feel like.
Except not elimination. We did substitution. All right, so let's do another one. All right, let's do 67.2. We have 2x minus 3y equals 5. 2x minus 3y equals 5. And we have 3x plus 4y. 3x plus 4y equals
Alright, so.
negative 18.
Alright, so yeah, but.
Am I going to eliminate x or y?
Y.
You're going
It's
to
got a
eliminate y.
Positive and a negative, so it's gonna be, you're gonna distribute the 4.
So
You're gonna
I
distribute
have
the
to multiply both of these equations. When one of the equations doesn't have a coefficient of 1, I've got to multiply both of the equations by a number because I want these coefficients to be opposite. What's the smallest number that 3 and 4 can be that go into each other? 12. I'm going to multiply this first equation by 3 the second, 4 rather, to make that 12. 4,
And then that one by 3. You just split.
and then this one by 3, yes. All right, so let's go and multiply every term.
All right, so it's gonna be 8x minus 12y.
All right, that's the first one.
9x plus 12y equals.
Negative 36.
Yeah.
Nope.
Nope,
It's a negative.
that's 2.
Negative 54.
Yeah, negative 54. 18 times 3, negative 54. Now I'm gonna add them.
Okay, so it's going,
My y's eliminate.
so it's going to be 17x equals
17x equals,
negative 54.
no, negative 54 plus 20.
Negative 20, wait,
28.
negative 24.
Um,
Oh, wait, negative 34.
Negative 34.
and then that's
And
going,
then it's
that's
gonna be x
going
equals
to be
negative 2.
Divide by 17,
x equals
x is negative 2. Okay, what do I do now?
I plug in.
Okay, let's just wait a minute. Let's just wait. Shh.
So it's all.
Let's give our brains a minute to catch up. And what did I do? Let's remind ourselves what I did. I wanted to eliminate y, so I needed them to be the opposite signs, and they are, but I needed them to be the same number. So I made them both 12. To make this 12, I have to multiply it by 4. 4. To make this 12, I have to multiply it by 3. I can't just multiply the y values by 3, because then that changes the value of the equation.
Okay, so now you're.
That's why I had to multiply every value by the 3 and 4. Now, Ben, I'm going to
So 2x minus 3.
back into the first equation, substitute the x value in to solve for the y. So we have 2 times negative 2 minus 3y equals 5. What's 2 times negative 2? God bless you.
Negative 4.
That's negative 4. To move to the other side, I'm going to
Wait, I thought it was gonna be positive 4.
2 times negative 2. Positive times a negative.
Oh. I thought it
It's
was
negative 4.
I was thinking square root.
All right, so it's negative 4 minus 3y is 5. I want to move the 4 to the other side. So I'm going to add the 4, right?
So it's gonna be negative 3 equals y.
Negative 3y is 9.
So it'd be negative
equals
3.
y.
Y.
Yes. Divide both sides by that
So it's
negative
gonna be
3.
It's gonna be negative 2 comma.
Y
negative
is
3.
negative 3.
Yeah, so it'd be negative 2, negative 3.
So I ordered pair, negative 2, negative 3.
Okay.
You said, okay.
Oh.
All right, let's go to example 4 on page 274. All right. Example 4 on page 274, and I will send this video out, okay, to everybody, the whole class. All right, let me write the original equations down, but you be looking at them to see what you are going to eliminate. So be looking at them and decide, am I going to eliminate x or am I going to eliminate y? All right, so we have 2x plus 5y is negative 7. 2x plus 5y is negative 7. 3x minus 4y is 1. 3x minus 4y is equal to 1. So someone on Zoom, what are you going to eliminate, x or y?
Why?
Good job, guys. You are
Yes.
genius.
Is that what you were going to say, Caitlin?
I was sleeping.
Do you see the reason that she chose y?
It was easier.
because one sign is positive, one sign is negative. Okay, what am I going to end up with as my coefficient for y? What's the smallest number that 4 and 5 go into?
Is it 20?
Yes, it's gonna be 20. So what do I have to multiply every term by in the first equation to make that a 20?
The first equation you have to multiply it by 4, and the second one you have to multiply by 5.
That's correct. That's Audrey.
That's Audrey.
That's Audrey.
Not so.
All right, we're gonna multiply every term in that first equation by 4. So 4 times 2x is 8x.
Did you resume your recording yet or no?
I did. 4 times 5y
Is
20y. 4 times negative 7,
-28.
negative 28. All right, see what we're doing? Now I'm going to multiply 5 by every term in that second equation. 5 times 3x is 15x. 5 times negative 4y is going to give me that negative 20y. And 5 times 1 is 5. What's my next step?
Wait. Do you subtract 5 on both sides?
Oh, you're gonna eliminate the y, right?
I'm going to add them.
Yeah.
So I eliminate the y. I'm going to add them.
X equals.
So how many x's do I have? 8 plus 15 is?
22.
Not 22, but
Oh, 23.
23x. My y's eliminate. Negative 28 plus 5 is?
Negative 23.
It's negative 23. When I divide both sides by 23, what's the value of x?
Negative 1.
Negative 1. That's x. Once I've solved for one of the variables, I'm going to substitute it back into one of the original equations and solve for the other variable. I'm going to go into the first equation. So 2 times the value of x is negative 1, plus 5 times y is negative 7. Negative 2 plus 5y, that's 2 times negative 1, equals negative 7. When I add 2 on both sides, I end with 5y is negative 5. And when I divide both sides by 5, y is also negative 1. So my coordinate pair is negative 1, negative 1. All right, we need to move on to the next lesson. Lesson 68. We have handled complex fractions before. And we've rationalized complex fractions. So a complex fraction is when I have a fraction in the numerator or denominator. It's not simply one value over another value. I'm having fractions in the numerator, or I'm having a fraction in the denominator. Remembering that these are all expressions. So the only thing I can do is multiply by what is effectively 1, anything over itself. So once I simplify the fraction in the numerator and the fraction in the denominator, I'm going to take the reciprocal of the denominator and multiply it over itself. All right, look at 68.1 on the top page 277. We have x over y plus 1 over y. That's the numerator. That's what makes it complex. All over x over y minus 1 over y.
Oh. Yay. I hate these kind of problems.
I have a common denominator in the numerator, so I'm going to move the sign up and write both of those terms over the one common denominator. See how I did that?
So you have another common denominator. So you
I
can X
do.
minus Y.
That's right. I'm going to do the same thing in the denominator. Now, I have a fraction over a fraction. That's where I want to get one fraction over a fraction. I'm going to take this denominator and I'm going to multiply by the reciprocal over itself. That's what is effectively 1. So I'll multiply by y over x minus 1, y over x minus 1. This value is really 1. The denominator cancels because we can cancel terms that are multiplied. And they're the exact same. Before we multiply, we simplify. We can only simplify terms that are multiplied. But look at this. I can simplify y to y. And now this is 1 and this is 1. 1 times anything is just that thing. 1 times anything is just that thing. All right, so I want you to see a pattern. Let's go back to this. So that you can know this pattern, because this is also in Algebra 2. When you have a fraction over a fraction, and your denominators are exactly the same, the answer is numerator over numerator. It's x plus 1 over x minus 1. Got it? That is the pattern. All right, you're not always going to have a common denominator. What time is it? Somebody tell me. We're going to do 68.2.
12:52.
Okay, we have time. All right, let's do the second example.
Wait,
Or-
12:52?
Yeah.
Oh, yeah, I forgot the wrong chapter. Wait, what time did we get out of 1?
Yeah, 1 of 5.
All right, look at example 2. We have 1
12 minutes till like hour.
plus 1 over x all over 7.
What would it be? 2 over?
I need a
1x?
common denominator. I have to have a common denominator. So in the numerator, I need a common denominator. What's going to be my common denominator?
1 over
X. This is 1 over 1. So I need to multiply this term by x over x.
So it's going to be 1x.
So it's going to be x over x plus 1 over x all over 7.
What? Okay. never
Isn't
mind.
x over x1, right?
Yeah.
Now I move that sign to the numerator. It's x plus 1. Write it over the common denominator all over 7.
That's the answer?
No, this is still complex.
Wait, what did you,
Divide?
yeah. And what did you eliminate, like the x's? Because
You
x
cannot
divided by
eliminate
x.
x because x is added to 1 here. But is this 7 over 1?
Yeah.
It is. I'm going to multiply by the reciprocal over itself. 1 over 7 over 1 over 7. You always take the denominator, multiply by the reciprocal to simplify a complex fraction. The denominator eliminates.
So it's going to be 7x.
1 times anything is,
So
so it's x plus 1,
over x, 7x.
7x.
And then that's now.
This is the most simplified solution. All right, let's do 68.3.
Is this our last one?
We're gonna work several of these to make sure we're good until time's up, all right?
Wait, 68.
68.3, bottom of page 277. Now we have 1 over x, and it is all over 1 minus 1 over x. Now I don't have a common denominator in the denominator. I need one. What am I going to multiply by?
X.
Yeah, we'll multiply this term by x over x to get a common denominator in the denominator. So we're left with 1 over x all over x minus 1 over x.
Then couldn't you just cancel it out, so it'd be just x over x is the answer? Oh wait, no.
I'm gonna move that sign to the numerator and the denominator and write this as 1 over x all over x minus 1 over x. Now I see the pattern. I see x is my denominator in the numerator. I see x is my denominator in the denominator. So it's numerator over numerator. You see that?
Yeah.
What? Oh,
Okay, we're gonna keep going. Let's go to 68.4 and then we'll do the last one too because it's resolving negatives and all kind of numbers for exponents.
don't we have
A over B plus 1,
Do we have a test next Tuesday?
no, the following. A over B plus 1, x over B plus 4. Now I need a common denominator in the numerator and the denominator. So what's gonna be my common denominator in the numerator?
B.
So I multiply this term by B over B,
It's gonna be 1 over B, or B over B.
B over B. And what about the denominator?
It's gonna be 4 over B.
I have to
4,
multiply
it's gonna be
this by
4, It's gonna be 4B
B.
over B.
over B.
So it's gonna be 4B over B.
So that I end up with A over B plus B over B all over X over B plus
B.
4B over B. Now I can write my numerators over their common denominator. So it's A plus B over B all over X plus 4B over B.
So now you multiply that reciprocal.
But I see the pattern. B is in both my denominators.
So it could be B over B plus.
So it's A plus B over
A would be over.
X plus 4B.
Oh, right, so if it's just B
Numerator
on the
over
bottom,
numerator.
if it just,
Oh, because B over B is canceled to 1.
Because when I multiply by the reciprocal,
if you multiply by reciprocal, it would be AB.
it would be B over X plus 4B all over B over X plus 4B. This denominator eliminates. My B's eliminate.
Wait, what?
Crisscross applesauce I can eliminate.
Yeah.
Terms that are multiplied, only terms that are multiplied.
Okay, I get it.
It's A plus B over X plus 4B. All right, last one, guys, last one, stay with me. All right. A to the negative 1x, A to the negative 1x plus B to the negative 1y all over x to the negative 1. All right, when it's negative, I move it to the denominator to make it positive. So this term is going to be x over a. I'm making the fractions. I'm moving b to the denominator. This is going to be y over b.
Oh, yeah, I remember.
Yeah. All over, this will be 1 over x. Now this one's more complex. We're not going to have the same denominators in the numerator and the denominator. I need a common denominator in the numerator.
AB.
AB. So I multiply this first term by b over b I multiply this second term by A over A. So that I end up with BX over AB plus AY over AB all over 1 over X. In the numerator, I move that sign to the numerator and write those terms over my one common denominator. So we have BX plus AY all over AB, all over 1 over X. I do not see the pattern. I therefore must multiply by the reciprocal of the denominator over itself. So I'm going to multiply by X over 1 over X over 1. My denominator eliminates. I distribute the X to both of those terms in the numerator. What's X times BX? X times BX.
BX squared.
BX squared plus X times AY. XAY,
Oh.
right? All over 1 times AB, which is just AB. So this would be your final answer. I've recorded all this, so I will send this link out. It will be available for about a week because it's Zoom. And I don't know how to upload a Zoom. I might look at that, uploading a Zoom